Welcome back. We are going to our next problem. An army contingent of 16 members is to march behind an army band of 32 members. Total 616 members is to march behind an army band of 32 members in a parade. Okay. The two groups are to march in the same number of columns. What is the maximum number of columns in which they march? What do you understand from the question? Nothing? Okay. First we need to understand which theorem we have to apply to solve this question. Here we are given, we have a total of 16 members in an army band and they are marching as a group of 32 members in a parade. Okay. These two groups are to march the same number of columns. So there are two groups, group 1 and group 2. These two groups are marching as the same number of columns. So in each column there will be same number of army members. We need to find the maximum number of columns. We know that as per the question, if the members in each column is same, we have the same number of, the two groups are to match same number of columns. The columns are same. These two groups are marching in same number of columns. What we have to find is, we have to find the maximum number of columns. Maximum number of columns. So, since it is in both the groups, since they are marching in the same number, that will be common. We have to find the maximum number of columns. We have to find the highest common factor. That means we have to find the HCF. So how we are going to find the HCF of two numbers? The numbers given are 616 and 32. So we need to find the HCF of 616 and 32. The highest common factor of these two numbers will be the maximum number of columns in which they march. There will be some tips which will be given in the question itself. We need to understand the question first, then it will be very easy to solve the problem. So, we are going to find the HCF of 616 and 32. The highest factor which we get from these two numbers will be the maximum number of columns in which they march. Okay. Listen carefully. Here A equals 616, B equals 32. We know that as per Euclid's division lemma, A equals B into Q plus R, where R 0 less than or equal to R less than B, where 0 less than or equal to R less than B. Okay. Then what we have to do as per Euclid's division lemma or Euclid's division theorem, or you can say Euclid's division algorithm, all are same. From the given two numbers, we have to take the greatest number and divide it with the smallest number. So I am going to divide 616 with 32. How many times 61? Once. 32 and 29. We will take this down. 6, 32 and 296. 9 times. 9 times how much? 32 into 9. It will come 288. Remainder will be 8. Right? Answer is right? Okay. Okay. Then our remainder is not equal to 0. R equals 8, that means R not equal to 0. Then how we can write? 616 equals 32 into 19 plus our remainder 8. So what we have to do? We know that if the remainder is not equal to 0, we have to continue the division until we get the remainder 0. So we will take 32 and 8 as the dividend and divisor, that is the divisor, and the remainder will be taken as the 2 terms for division. So we will be taking the highest number, which is 32, as the dividend, and the smallest number, the remainder, will be taken as the divisor. 32 and 8. How many times? In 32, 8 5s, 4, 24, 4 times, 8 4s are 32. Remainder is 0. Okay, then how we can write here? R equals 0. So 32 equals 8 into 4 plus 0. 8 into 4 plus 0. Then what will be the HCF of 616 and 32? HCF of 616 and 32 will be 8. Is it clear? Listen carefully. HCF will be the divisor term. What we are writing is dividend equals divisor into quotient plus remainder. Once we get remainder equals 0, then our HCF will be the term in the divisor position. So HCF of 616 and 32 is equals 8. That means, therefore, maximum number of columns in which they march equals 8. Maximum number of columns in which they march equals 8. Very easy. You can just note it down. We are moving to our next question. That is, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. We have discussed this type of problem before, but I am going to show you the square of any positive integer is of the form 3m or 3m plus 1 for any integer. Yeah, that doesn't matter. Okay. We know that A equals B into Q plus R. As per what? As per Euclid's division lemma, A equals B into Q plus R. Here it is given square of any positive integer is of the form 3m or 3m plus 1. 3m or 3m plus 1 means here B will be what? As per the question, B will be B equals 3. Because this is of the form A equals B into Q plus R. Here it is given 3m or 3m plus 1. So B equals 3. Okay. We know 0 less than or equal to R less than B. And once B is given, then we know the possible outcomes of remainder R. So possible remainders will be what? Possible remainders are, remainder R will be always less than B, so it will be 0, 1, 2. Because B equals 3, R will be less than B, so possible remainders are 0, 1, 2. Now we are going to substitute this equation. We are going to substitute this value of remainder in our equation 1. Okay. Substituting the values of R in equation 1. Okay, substituting the values of R in equation 1. So, when R equals 0, A equals what? B is 3. 3q plus 0, which is equal to 3q. When R equals 0, A equals 3q. This is just direct substitution. When R equals 1, A equals 3q plus 1. When R equals 2, A equals 3q plus 2. Okay. This much is clear? No doubt? Okay. Now, what we have to find? We need the square of any positive integer. Here we got only A equals 3q, a equals 3q plus 1, a equals 3q plus 2, etc. But what we need is, we need the square of this value. We need the squares of 3q, 3q plus 1 and 3q plus 2. So, I am going to square each of these values. So, how it will become? Now, 3q whole square. 3q whole square is 3 square, 9 into q square. Okay, 9 into q square. The form which I need as per the question is 3m. 3 and some variables which should be in the form of m. So I am going to write this as, I am taking 3 as common, 3 into 3q square. 3 into 3q square. And I am going to write it as 3 into m. I am going to substitute 3q square with m, where m equals 3q square. No doubt, just a substitution. We need it in this form, a multiple of 3, a product of 3 into m. So I just took 3 from 9q square and it became 3 into 3q square, which is equal to 3m, where m equals 3q square. Okay, now next value is 3q plus 1. I am going to take the square of 3q plus 1, that is 3q plus 1 whole square. This is of the form a plus b the whole square. We have studied that a plus b the whole square is what? A square plus 2ab plus b square. A square, a plus b the whole square equals a square plus 2ab plus b square. So we are going to apply this rule in this a plus b the whole square. So 3q the whole square plus 2 into 3q into 1 plus 1 square. It will be 3q the whole square is 9q square plus 6q plus 1. 9q square plus 6q plus 1. So I am going to take, we need in the form of 3 into something, 3 into m or 3 into something. So I am going to take 3 from this. These two 3 is a common factor. So I am going to take 3 from these two. It will become 3q square plus 2q plus 1. I am going to substitute this with m, that is 3m plus 1. That is 3m plus 1, where m equals 3q square plus q. Okay, where m is 3q square plus 2q. Then what's our next term? 3q plus 2 the whole square, right? 3q plus 2 the whole square. I am going to take the square of this. Same, a plus b the whole square. It will become 9. Okay, I will write it in the expansion form first. 3q the whole square plus 2 into 3q into 2 plus 2 square. A plus b the whole square. It will become 9q square plus 2 to the 4, 4 to the 12, 12q plus 4. Okay, 9q square plus 12q plus 4. But I need something in the form 3m plus 1. So what I can do? I am going to make 4 as 3 plus 1. That I can do. 3 plus 1 is 4. So 9q square plus 12q plus 3 plus 1. I have written 4 in the form 3 plus 1, a sum of two numbers. It is also 4, so we can do it like this. So I can take a 3 as common factor from these 3 numbers. So it will become 3 into 3q square plus 4q plus 1 plus 1. What I need is, I need it in the form 3m plus 1. So if we have written it as 4, then we can write it in this form. So what I made is, I made 4 as 3 plus 1 and took 3 as a common factor of these three numbers. So it will become 3 into 3q square plus 4q plus 1, and we can write it as 3m plus 1, where m equals 3q square plus 4q plus 1. Okay, hence the proof. Hence the proof. It is proved. So we can use Euclid's division lemma to show that square of any positive integer is of the form 3m or 3m plus 1. This is just a substitution. We are substituting that term with variable m, and we need to write m, the value of m as well. Here m is 3q square plus q. So we can directly substitute it with m, and we need to note what m is, where m equals 3q square plus 2q. Okay.